Let us continue with the important questions from matter in our surroundings. First, give reason. A gas fills completely the vessel in which it is kept. So if you see on the right, irrespective of the gas, irrespective of the size and shape of the cylinder, the gas will fill the cylinder, fill the vessel completely. That is because the particles of gas are moving freely in all directions because they have less forces of attraction between the particles. Because they have less attraction, they can move randomly anywhere and they take up the shape of the container and they fill the vessel completely. A gas exerts pressure on the walls of the container. Now, as we discussed the previous question, the particles are free to move. There are less forces of attraction between the particles, due to which when they are moving freely, they collide among themselves. So gas particles collide among themselves and their kinetic energy increases. At the same time, they start colliding or exerting force on the walls of the container. So as the particles, so if these are gas particles moving in all directions randomly, they come and collide with each other, because of which their kinetic energy is maintained, and they also go and hit the walls of the container. Now when they hit the walls of the container, they are exerting force on the container. That force is nothing but pressure. A wooden table should be called a solid. We shall call this wooden table a solid if it shows us the properties of solids. If it has properties of solids, then we can definitely call it as a solid. Example of a solid. Like any other solid, a wooden table has definite shape and volume. It is very rigid. It cannot change its shape easily, or unless we apply force, it cannot change its shape. So it has the properties of solids, hence we can call it a solid. We can easily move our hand in air, but to do the same through a solid block of wood, we need a karate expert. Now in the previous video, we had a similar question where we said a diver is able to cut through water. There we spoke about the observations that we see. The observations were in terms of interparticle attraction and interparticle spaces. So same thing applies even here. If we are able to move our hand in air, that is because the interparticle attraction is less. Air is a gas, and in a gas, interparticle attraction is very, very less, and the interparticle spaces are very large. So we can easily move our hand in air. But we just saw the previous question. We said a wooden table is solid. So if it is solid, that means it has properties of solids, which are strong forces of attraction and very less space between the particles. In which case, the wooden table or anything which is made out of wood will be a solid and it will be rigid. So we will not be able to cut through it, or you know yeah, of course, karate experts can do it because they have practice and they have that strength by which they can cut the wooden table itself. That means they are breaking it, they are applying force and changing the shape of that solid. The last one, liquids generally have lower density as compared to solids. But you must have observed that ice floats on water. Find out why. Now, density we have already spoken in the previous video. Density is mass by volume. And I told you that solids have highest density then it's liquids, and the least density is in case of gases. Now, ice is a solid and water is a liquid, which means ice is supposed to be more denser, and if it is more dense, it should not be floating on water. But we see that ice floats on water. Why? Why is it possible? We cannot make a wooden table float on water. Then how come ice floats on water? That is because ice has a lot of empty spaces in its structure. Now, if I have, say, if we have 10 ml of water, and if we are freezing that 10 ml of water, the volume is same, but the mass occupied by ice will increase. Same 10 ml of water is converted to ice, the mass will increase. That is because when water is freezing, when water is freezing, it freezes in such a way that it forms a crystalline shape with lot of gaps between the water molecules. So there are a lot of empty spaces in ice. There are a lot of um, empty spaces in ice. Now, because of this empty spaces, the hollow spaces, ice becomes lighter. It becomes less dense, and it is able to float on water. So when water is freezing, it expands. The water expands. If you take 10 ml of water, take 10 ml of water in a container, you will mark the level of the water and let it freeze. Later you will see that ice would have occupied more space. That clearly shows that when water freezes, it expands. That means it has a lot of empty space inside, which makes ice lighter, and ice can float on water because the density will be less.